All right, continuing along with yesterday, or with the last video here. Sorry, getting a little punchy. So anyway, we had the sketch, and now we are looking at and moving on to question C here. So how would the equation change if the person breathes more rapidly? So provide an example. So for C part here, so if the person was to breathe more rapidly, what's happening? So if I ask you to breathe quicker than you are already, I know, like I said, you're already breathing quick because you're watching my video, but breathe a little bit more rapidly, what you would find is that the time it takes for a full breath would decrease. So time for a cycle decreases. So how does that affect our overall equation? Well, K was already 360 divided by the period. And before we had P at 4, what about if we double our breathing? So let P equal 2. So that would mean that our K value is now 360 over 2, which is 180. So our equation from above now would look like this. So y equals amplitude would remain the same. The sine of 180 now, x plus the 2500. All right, so the change is right here. So therefore, K value would increase. All right, so that's what would happen to our equation. All right, on the D part, moving all the way up. How would the equation change if the person was to take deeper breaths? So if you started to, hyperventilate because you're enjoying the video so much, what would happen to the equation? So don't shut it off to stop the hyperventilating. Let's talk about that. Larger breaths. So that would mean you're taking in more air. So intake, more air, which would mean you'd also expel more air. So things would balance out. So what's really changing? Your body's going to maintain that medium up there. So it's not going to move the constant or how much air is in there. And on average, what we are doing here is we are influencing or changing our amplitude. Changing amplitude. So before, we had an amplitude of 300 milliliters. So now, let's say we double our intake. So taking a deep breath doubles it. A would now equal 600 milliliters. So that leads us to rewriting the formula. So it would look like this, y equals 600. And then if we go back to the original, doesn't matter which one you would have picked here. Okay, well there is the change right there. So therefore, deeper breathing. Deeper breathing influences amplitude. There you go. So there is the second question taken care of. And like I said, I've kind of taken a cross section. I've picked A, B, C, Ds that are representative of the different types of questions you're going to look at. Last example here. Last example for this unit. So pendulum swings back and forth. So for those that don't know what a pendulum is, I'll draw the diagram to start with. So it's basically a free hanging object with a weight on the end of it. It will swing from side to side once you get it going. All right, see the motion. It's like that. Okay, each swing takes 12 seconds. So that would mean that if I started here, so here's my start, it would go out, it would then return, and come back to the end. It would take 12 seconds. So that is our period. So our period is 12 seconds. If the pendulum swings 105 centimeters on either side, so that's the distance it's traveling side to side, so it moves 105 this way. It also moves 105 that way. Oops, 105 whatever, that way. So that becomes our amplitude, our A value. And you can work in centimeters, you can work in meters, doesn't really matter as long as you're consistent. Answer the following. So A part's determine a model for the situation. So because I'm going to start at the baseline or the center line, I'm going to choose the sine function. All right. Sine is probably one of your safer bets. However, cos, if you can't change your starting position, if you're starting at a max or a min, you want to choose cos, and you're going to find that from experience as you go through the examples. So again, I'm going to choose sine graph here, a sine k, x minus p plus q. So I have to do a couple calculations. I need to know what k is. K is 360 over p, which is 360 over 12, which is 360 over 30. All right, so we have a k value. I have an a value already. So 105 sine k value is 30. Now, the nice thing, and the reason I pick sine, because I'm going to assume the pendulum is starting right here in the middle, that means that there's no phase shift. So P is 0. So I'm going to put in the original line here, no phase shift because it's 0. And the nice thing with this one as well, Q is how far you are from the origin. Well, if we made this into an XY axis, but I'm going to turn it on its side, so really this is Y. That is a terrible looking Y off to the side. And then the other axis would be our X. So let's try that one more time. Y axis and X axis. So I'm just changing my orientation. So what that would mean is that I'm still on my origin or on my center line. So therefore Q is going to be equal to 0 as well. All right. So the final equation is just going to be 105 sine of 30x. So there you go. There's A part. Once you have the model, you just go ahead with what you have. All right. So determine the location of the pendulum after 16 seconds. So we are basically let our time, or let t equal 16 seconds. All right. So over here, I'll just put in let y be our displacement, and x is our time. So that would mean that y equals 105 sine 30 times 16. So you're just plugging that right into the calculator in order to solve. So again, make sure you do the 30 times 16 equals first. Then you take the sine of it, then multiply by the number out front. So it's very important that you are using a calculator that you know you'll have on the test. Times 105. So I get 90.9 centimeters. So therefore, it is 90.5 centimeters from the rest position. When I talk about rest position, that's where it would normally hang if we weren't swinging it. All right. So there's B answered. C part, determine when the pendulum will be at the rest position. So when does the rest position occur? It occurs when y is equal to 0. It's 0 distance. So here we are letting y equal 0 centimeters. So this is the equation we get. 0 equals 105 sine 30x. So we're solving for x here. All right. So divide both sides by 105. 105. Now 0 divided by 105 is still 0 sine 30x. Take the sine inverse of both sides. So sine inverse of 0 is equal to 30x. Divide both sides by 30. And we'd get x equals the sine inverse of 0 over 30. Now let's talk about this for 1 second. Because we're talking about the rest position, this one's actually a little easier to visualize than the previous example. We know we started it at the middle here. We know that we go to a maximum amplitude of 105 and a minimum or a trough of negative 105. And we know that it takes, we talked about this, 12 seconds to repeat. So 12 seconds to repeat, that means at 24 seconds it would repeat again. Halfway through the cycle would be 6 and 18. So that means that you'd end up with a graph, as best I can sketch it, that looks like this. So this is 2 cycles. Okay, So this is one complete cycle right here. All right, that's one complete cycle, 12 seconds, and then another complete cycle. So when is it at the rest position? Well, it's at the rest position at 0 seconds. And if you plug this bottom into the calculator, you're going to get an answer of 0. Okay, so obviously that's going to be the first one. I use the word obviously because now that we have the graph, we can see that. When else is the sine function equal, or when does sine inverse also equal 0 again? So what we're looking for are these locations, everywhere it's at the rest position. So in this case, the diagram is actually more useful than this. So I'm just going to state, therefore, from diagram, it will return every 6 seconds to the rest position. All right, there we are. So it returns to the rest position every 6 seconds. All right. From the equation, like I said, and I talked about this in the previous example as well, if you plug that into the equation, you're going to get 0 degrees. This is actually going to equal, and I'll just change colors for a second here. You're going to x equals 0 seconds, okay? So that's not all the answers, and that's why that sketch is important to remind you with a periodic function, that height or that location occurs more than once. If we were looking for when does it reach the max, you'd have 1, 2, and that would be occurring every, that's one full cycle. So it's every 12 seconds, it would be at positive 105. Every 12 seconds, it would be at the trough. So every 12 seconds, it would be at negative 105. So that's why the sketch is really important. And as you go through these examples, so here's the assigned homework out of the book, you're going to run into a couple questions like this. So at that point in time, make sure you sketch the graph first so you have some sort of visual aid to help you out. And then what I can do is I'll provide extra assistance as we move through. So anyhow, that is Unit 3. The review will be posted there on the website, so you'll be able to download that, and you can work your way to preparing for the Unit 3 assessment. Good luck with that, and we'll see you in Unit 4.